All right, so as promised, we are back with a second video. I'm talking about the areas of trapezoids. So we're going to look at a second formula. The first video we learned the formula A equals, and I'm going to write this up at the top here so we can reference this later. A equals 1/2 the height times b1 plus b2, the sum of the two bases. So that's one way that we can find the area of a trapezoid. Now, the other way is we can use another formula, which you can kind of see in the middle of the page, which says the area is equal to the height times the median. So let's kind of just quickly review what a median is. So the median of a trapezoid is the segment that connects the midpoints of the legs of a trapezoid. Okay, so that's what a median is. Now, the second thing that you need to remember about a median is that the median is equal to 1/2 the sum of the bases. And this is a theorem that we learned about quite some time ago. All right, but again, that's true. The median is equal to 1/2 the sum of the bases. So if you look now at the formulas, I'm going to grab a highlighter real quick. So here's our original formula, and one thing that's highlighted in yellow, that's the original formula. And what I want to do is I want to highlight a couple things in there. So I'm going to grab the different color highlighter. So if you look, you see there's some similarities between this formula right here, which I'm highlighting in purple, and the formula that's highlighted in yellow. So the first thing that we see is, whoa, we don't want that. Let's try that again. Grab the red again. This is 1/2. I guess I'll just circle it. All right, here's the half, and here's a half. And then we've got this B1 plus B2, and we have this B1 plus B2. And the only thing that remains is the height. So again, I'm grabbing a highlighter. So here's the formula that we're looking at, the new formula. And if you look, the height is right here. So underlined in purple in both. And then the median is just replacing, or the length of the median is replacing the 1/2 B1 plus B2. So that's why this formula works as well. So if you know the length of the median, um, then, and you know the height, this just gives you kind of another option for finding the areas, excuse me, the area of a trapezoid. So let's go through and do some examples, and I'll show you how to apply this. So let's take a look at example number 3. It says find the length of the median and the area of the trapezoid. What I'm going to do for you is just to demonstrate that both formulas will work, because in this case we could again find the area of this trapezoid either way. So let's go ahead and do that. So first thing, let's find the length of the median. So the median is equal to 1/2 the length of the bases, so 18 plus 24. So in this case, the median is 21. So to find the area of this trapezoid, we can do 1/2. I'm sorry, not 1/2. It is just the height times the median. So the height is 16 times the median, which is 21. And that gives us a total area of 336 square units. Now, alternately, we also could have used the original formula, so the area equals 1/2 the height times B1 plus B2. So let's plug that stuff in. 1/2 the height is 16, B1 is 18, B2 is 24. And again, if you go through and evaluate this, you get 336 square units. So either formula is going to work for you. Let's take a look at example number 4. It says if the area of the trapezoid is 128 square feet, find the height. So in this case, you got to kind of figure out what you know and what you're missing. So we know the area. That's given to us right here. We know the length of B1 and we know the length of B2, and what we want to do is find the height. So in this case, I'd probably use the first formula that we learned. So here we go. So again, I'm going to plug in 128 because we know the area. We don't know the height, so I'm going to leave that as the variable h. And then B1 and B2 would be 12 plus 20. So now what I'm going to do is I'm going to kind of rearrange things over here. So 128 is going to equal, what I'm going to do is I'm actually going to distribute this 1/2 to this sum. So 12 plus 20 is 32, and 32 times a half is 16. So that's going to give us 16h. We'll divide both sides by 16, and h ends up being 8. And in this case, we know that the original area was square feet, so the height in this case is 8 feet. All right, let's take a look at example number 5. Here it says if the area of a trapezoid is 189 square centimeters, find the length of the other base. So same deal. Here we know the area. This case we know one of the bases, or the lengths of one of the bases. We know the length of the height, and we're trying to determine the length of the second base. So I'm going to use the same formula, 189 for the area equals 1/2 the height, which is 9, times the sum of the bases, which is going to be 15 plus b, because we don't know the other base. So I'm just going to start simplifying a little bit. 189 equals 1/2 times 9, which is 4.5, times 15 plus b. At this point, you've got options. You can distribute the 4.5 through the parentheses. What I'm going to do is divide both sides by 4.5, because 189 is divisible by 4.5. It actually equals 42. So 42 equals 15 plus b. And then to determine the base, we're just going to subtract 15 from both sides. So b is going to give us 27. And the original units were square centimeters. So this would be 27 centimeters. Okay, a couple more examples to go. Let's take a look at example number 7. So this reads that, that we want to find the area of the isosceles trapezoid. So in this case, we don't know the height, and that's the big problem here. So what we want to do is we want to find that height. So what I would do, I always like to try to incorporate triangles in if I'm missing. So like triangles, rectangles, if I'm missing any dimensions that I need. In this case, it's exactly what I'm going to do. So if I drop in those altitudes the way that I did, what ends up happening is I make a rectangle and 2 triangles. So this dimension has to be 18 because these 2 sides would be congruent, or those 2 pieces would be congruent. And what that leaves us with, 30 minus 18 is 12. So these 2 additional pieces have to be 6 each. Now this is nice because, and I'll highlight this, what we end up with are 2 congruent right triangles, and we'll be able to use the Pythagorean theorem to solve for h. So now we'll know the height and we'll know the length of both of the bases. So this is actually a Pythagorean triple. So h is going to be 8. Again, if you don't recognize that that's a Pythagorean triple, you can always use the Pythagorean theorem and you should get that h is equal to 8. So we have all the information that we need. The area is 1/2 the height times the sum of the bases. Height in this case is 8. Base 1, we'll call that one 18. Base 2 is 30. And when we simplify all that down, we end up with 192 square units, so 192 square units. All right, one more example. This is find the area of an isosceles trapezoid with a 60-degree base angle in bases that are 9 and 13. In this case, clearly we do not have a diagram, so my suggestion would be to draw one so that way you can label it with the given information, label it with your knowns, and also with your unknowns. So I'm going to do my best to draw an isosceles trapezoid. Off to a bad start. Okay, so something like that. Isosceles trapezoid, the bases are the same. I'm sorry, the base, not the base is the same. The legs are the same. Base angles are the same as well. All right, so I'm going to label this diagram with what I know. I know that this has to be 60 degrees. I also know that one of the bases is 9, so the shorter base is 9, and the longer base is 13. Now, we're kind of in the same situation that we were in problem number 6, where we don't know the height. So I would use basically the exact same technique to get started on that. I would drop in these altitudes and kind of break this trapezoid up into a rectangle and 2 triangles. So if we do that, this piece right here is 9. And then if we subtract 9 from 13, we end up with these 2 remaining pieces equaling 2 units apiece. Okay, so what we need is the height. So again, similar to a problem that we did before, this right here, which I'm highlighting green, that right triangle that I'm highlighting in green is a 30, 60, 90 triangle. And we know that 2 is the short leg because it's opposite the 30-degree angle, which means that to get this height, we need to find the long leg of that 30, 60, 90 triangle, which is going to be the square root of 3 times the length of the short leg, so 2 root 3. And again, we got everything that we need. The area rather is equal to 1/2 the height, which is 2 root 3, times the sum of the bases, which is 9 plus 13. And if we do that out and round that to the nearest tenth, we get about 38.1 square units. All right, so for the evidence of learning in this section, you're going to end up doing these problems right here. And then these problems right here. I don't know if I eliminated that table or not. All right, but those are posted to Google Classroom. So as always, if you have any questions or concerns, let me know. I hope this video has been helpful, and we will see you in the next one.